Hello, this is Dr. Oz. In our last video, we talked about the importance of inventory, and we talked about this given information for this purse company. And then we ask ourselves, what's the objective in this model? And we say we are trying to minimize the total cost. And to calculate total cost, we need to calculate ordering cost and holding cost because they are giving to us holding cost here and ordering cost. And if I add them up, I will get the total cost. And ordering cost formula we calculated based on number of orders per year times unit ordering cost, and holding cost number of inventory each day that I have times holding cost rate per day. All right, so let's create our inventory simulation here. I would like to start with the day information. And I have 365 days. So 1, 2, I can go all the way down to 365. All right. And since I have 365 model duration, now I need to keep track of inventory at the beginning, demand, and amount order. So beginning inventory, demand, ending inventory, and finally amount ordered. All right, so the beginning inventory here is given at the beginning of first day is 200 purses. Now I need to generate a random number based on discrete uniform distribution for demand. So I need to use Excel rand between function to generate a random number between 10 purses and 30 purses. As you see, this is my random number, and your number will be different than mine. Whenever you press F9 or change something in Excel, this number will change. All right, don't worry about it. There's a random demand because we don't know exactly what demand is going to be, but we know the behavior of it's between 10 and 30 with equal probabilities. Now I can calculate my ending inventory by beginning inventory minus the demand. That's how many units I have. Now I can decide whether to order or not. I need to use if function here. If my ending inventory is less than or equal to my reorder point, that means that I need to order some. How many units do I need to order? I need to order quantity, which is not here. We haven't entered it yet. So let me just choose this empty cell here, and I will put my order quantity here. Otherwise, 0. Right, so let's enter this parameter here. Lot size or order size. This is Q in our model. I will represent this with Q. And let's say whenever we order 500 purses. And again, this number right here is, I will color this one yellow because this is a number that I have no idea about, because this is my decision variable. And I don't know the value, right? I'm curious about this value. All right, because based on this, all my costs will change. All right, as you see here, I'm not ordering any because I have 188 units ending inventory, which is greater than 100 units. So I don't need to order any, all right? Since I would like to drag this formula down, I need to make sure that some of those cells are locked in. So I need to lock, I don't need to lock I10 because I want to keep track of ending inventory when I drag it down. I need to lock in my C10 because I would like to reference to reorder point, which is a fixed number, F4. And same thing here, my Q, I want to always reference back to this cell. So I press F4 to put dollar signs in front of the letter and the number in my cell reference so that they are locked in, right? So I would like to now calculate the beginning inventory for day 2, which is my my ending inventory, right? Plus, this is gonna be my ending inventory from previous period plus amount ordered. So if I order, of course, an assumption in this model is that the order that I have will be delivered next day. So the lead time really would be, in this case, 0. So then you may say, why this is lead time 5? I was just assuming that, so it's really not 5. Actually, lead time here is 0. Whenever I order, that order will be delivered next morning. So you may think this one is a 5-day, maybe it will take up to 5 days. That's why I'm very conservative. I make my plan based on that. Okay. So this is my ending inventory. So if I just drag it down, then I will get my values here. All right. So I will just double click on right down corner, and here are my beginning inventory values. So now let's look at the demand. I would like to reference the sales. So I would log in. I log in this one too, and then I can copy this formula down as well. And let's look at the ending inventory, which is beginning inventory minus demand. Okay, that looks good to me. Right down corner, double click. I copy this formula down as well. And let's look at this one. Okay, I reference this too, and I like them. So I reference here. I don't like that one. That's good. So let's copy this one down as well. Perfect. As you see here in day 5, I order based on my quantity demanded. The reason is that my ending inventory here is less than 100 units. That's why I order, because that 97 is less than or equal to my reorder point. Beautiful, right? So this is my inventory model right here. So based on these values, now I can calculate the annual ordering cost, okay? So let's calculate my annual ordering cost. So I know that annual ordering cost is number of orders per year. To count that, I need to use Excel function, which is called count if. I count if amount ordered column if this value is greater than or equal to, if this value right here in this blue array is greater than or equal to 0, right? If that value is greater than or equal to 0, that means that I ordered something. All right. So as you see here, if I count if number of items that are greater than, sorry, not greater than or equal to, I need to delete the equal sign, because if it's 0, that means I'm not ordering. If it is greater than 0, that means that I'm ordering. So I need to count these values. All right, so it looks like I ordered 15 times in this model. Again, if I press F9 based on my random numbers, this could change 14, 15, and so on. So this is number of orders per year times I need to multiply that value with unit ordering cost. In this case, my unit ordering cost is given to me, which is $200 per order. So if I multiply these two values, that will give me my ordering cost, which is $3,000. All right. So now let's look at the holding cost component. So number of inventory each day, right? So number of inventory each day. So how can I do that? I can basically add up all these inventories. That will show me how much inventory do I have, and it looks like I have 120,000 inventory. But this doesn't mean that this inventory stays there for whole year. So if I want to find average inventory per day, because this is average inventory per year, I need to divide this value by number of days. So if I do that, that will give me, on average, I have 328 units of inventory in my model. All right. So this is number of inventory, number of units in inventory per day. And if I multiply this value by holding cost per day, and please make sure that these units do match. This is per day, this is per day, otherwise it wouldn't work, right? So I need to multiply this value by holding cost per day, which is given to me average holding cost per day per. So it is $100, okay? So if I multiply these values, then that will give me my holding cost, which is around $33,000. All right, so now I can calculate my total cost. This plus this, all right? So that's my total cost. All right, so what is next? So we build our model, and this model really calculates our total cost based on the lot size of 500. But as we talked about, that lot size of 500 is a decision variable. So I'm curious what would happen if I replace this by 400. Looks like my total cost decreases. But if I go 300, that is decreasing again. What if I go with 200? Oh, that decrease again. What about if I go with 100? It starts going up. What about if I go with 50? It's going up again. What if I go to 1? You can see that if I go with 1, basically it doesn't work because my inventory goes negative. That doesn't make any sense. Let's go to 50, and you can see the cost is going up. So cost is going down, 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 and then after certain points, start going up. Instead of trying this one by one, I could do a sensitivity analysis, all right? So let's create a sensitivity analysis section here. All right, so here I would like to try different values of lot size. Okay, so to conduct sensitivity analysis, I will use one-way data table in Excel, one-way data table. All right, so let's do that. I will change different lot sizes, and I will keep track of ordering costs, holding costs, and total costs. Okay, let's do this. So lot size, to do, by the way, one-way data table, I need to leave one cell empty. That's the way Excel wants me to build. So I will start here, the different values of lot sizes. Let's say I'm curious about 50, 100, 150, and all the way up to, let's say, 600. I'm curious about these values, or I could go even more. If you want to go more, you could go more, but I think this should be fine. All right, so my ordering costs, right under it, I need to reference that value. So I calculate my ordering cost right here. And I calculated my holding cost right here. And total cost is right here. All right, so now I can build my one-way data table starting from the empty cell. I highlight the entire table, Control-Shift right arrow, Control-Shift right arrow, Control-Shift down arrow, Control-Shift down arrow to highlight the entire cell. Or you could just use your mouse to highlight the entire table. All right, now data, what if analysis, data table. Here, Excel is asking me what's my row of input cell. Basically, I do not have any inputs in my row. These are my output cells. But I have my column input cell. In this case, it's lot size Q. These are my inputs. So I would like to change these inputs, which is lot sizes, and then calculate these outputs, which are ordering cost, holding cost, and total cost. So my column input cell is right here. I want Excel to change this value for me based on the values that I provide here. One by one, Excel will plug in those values right here, I know that my calculations in my model is based on this, so all my calculations will be updated, and I will get these output variables values, and then I will print them right here. All right, click OK, and as you see, it's done. I don't need to do them one by one, and you can see these costs. Beautiful. So now what I can do is I can visualize these results. So what I would like to do is to visualize these results. I will include a line, 2D line graph. So I will highlight these 3 columns and then insert. No, I don't want that, sorry, because this is my base scenario. I would like to highlight these 3 columns starting from here. Insert line graph, and I will use the first line graph option right here, and this is my graph right here. Beautiful. Okay, so my chart title here is inventory costs for different lot sizes. Okay, and here let's add our axis labels. Axis titles right here. So these are right here the cost numbers in dollars, and here these values are lot size Q values. All right, so let's label these data as well. So what I'm gonna do is right click on this line and select data. Here I would like to name my data. So it's not serious one. I will edit this. This is ordering cost. Okay. And the second data set here, edit, is my holding cost. Okay. My third data set here, edit, is my total cost. Okay. And these lot sizes are not 1, 2, 3, 12 either. Let's change our axis, horizontal axis labels as well. Click edit. And those values are 50, 100, all the way up to 600. So click OK and click OK. Now you can see what's happening here. As you see, the ordering cost goes down and down when I increase my lot sizes, as I expected. But as you see, the slope is going down as well. On the other hand, the holding cost is going higher and higher. And the intersection point between the ordering cost and holding cost gives me the total cost that is the lowest, okay? Somewhere around here, between 100 to 100, I would say total cost smallest here. Somewhere between 100 to 100 is my lowest cost. So in this case, really, 25,000. We can look at here, it's easier. So somewhere here, between 150 and 200, this is my best numbers. Of course, if I press F9, the graph will change a little bit, but it looks like in general, 150 to 200 is my best lot size that will minimize my total cost. So let's take a look at the inventory position for this model. So what I would like to do is insert another line graph for ending inventory position. So I will highlight Control-Shift-Down, highlight the entire column, and insert line graph, 2D line graph here. Looks like this is hard to see here. I'm thinking, how would I make this better? Let me see whether I can make it bigger to make it better. It still looks a little too crazy. So what I'm gonna do, maybe that Just thinking what to do. So this ending inventory position. There's something, I think there is some kind of a oh, okay. The reason that this is so crazy is that because my order quantity is 50. All right, that makes sense. So let's put this chart somewhere at the top. Oh, it takes so much time. That's the problem with Excel. Let me just zoom out. This will be easier. All right. So, well, it takes so much time to really carry this one. Zoom out and then carry it right here. This is going to be easier. All right. So this graph is so messy because I'm ordering basically every 50 units. So every other day or so, I'm ordering. So instead, if I just change to my original value, which doesn't impact my scenario analysis or sensitivity analysis here, if I put 500, this graph will look easier to understand. So in this case, you can see the days in my x-axis. So let's add the chart axis titles. So these are my days. And these are my number of purses. As you see in my inventory, I started somewhere here and the inventory fell down with the demand, and then all of a sudden I got 500. Goes down, 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 and around first month I order again. Around end of second month I order again, and so on. So you can see the inventory position here, and as you see here in this problem, I never really reach inventory position that's negative because my reorder point that I entered here is 100. But if you put this value as let's say 20, then you may see the inventory can go down to negative numbers. So that's why identifying reorder point is very important concept as well. So in this slide presentation, we talked about calculating total cost and doing inventory simulation, and then see the ending inventory positions. And as you see here, in this model, we can minimize our total cost by considering ordering cost and holding cost. That's it for this video. Enjoy supply chain management.